Hi there, my name is Prithviraj Keswani, and today's date is Sunday, March 21st. And today we're going to be talking about data structures. More importantly, trees and how important they are in data structures and what exactly they do. So to begin first, we need to understand what a data structure is. A data structure is a way of storing information and making it more efficient and making it compile faster. Making it more efficient. So to continue on, we have two types of trees. We have two types of data structures at first. We have linear and non-linear. Linear data structures are pretty much something that have a start and an end, and A and B. Let's just say this is our start and the end. And they're more or less sequential, which is like, that is pretty much it for linear. For non-linear data structures are something that simulates relationships using like a hierarchical relationship system. For example, a family tree. In a family tree, you will have your ancestors and your great-great-grandparents and your great-grandparents and your parents, and then you. That's what a nonlinear data structure is. And moving on, a tree itself organizes data in a hierarchical structure. So data is not really in linear, and it multiplies from links and nodes. We will talk about links and nodes now, and how a logical tree looks like. So right here we have our first value going on, 1, 2, and then right here, moving on. So this can have any value inside it. That doesn't make a difference what number is inside for now. Yeah. So the first value on the top of the tree is called the root. And then the root is basically our first value of the tree, where the tree starts, and it's the entire tree references from the root. It does not have a parent. A parent is the second value. Basically, what is an image? It's right after a root, right after a node. So these little circles itself are called nodes. So 3 and 7 are parents here, and so are 4 and 5. And then 8 and 7 here, for example, are our sibling nodes. Just because they are from the same parents. That's what we need to know as well. Moving on, we also need to understand leaves. Leaves are the last nodes in the trees and how important they are at times. There is no node after this one. Edges or links are what these lines are that connect the tree, that connect all nodes, and also these are called links as well. So these links, and so what next thing we have is a path. A path is what from the top node is from the successive edges of the source node, from the first node to the last node, or you can say from a chosen node to a specific ending node. So here we can say the path from 2 to, what is the path from 2 to 6? So we have 2, then we have 3, then we have 5, and then we have 6. That is our path right here. Moving on, trees are more or less recursive, and it's the depth of the node itself, like how deep the node itself is, represents the edges of the trees from the root node. The height is the node is the number of edges in the longest path, and the height of the tree is depends on the height of its root node. So the main application for trees itself is storing data in a folder-like structure, more or less in an organization way. Storing data in an organized way. It can even lead on to UML and XML diagrams. And then it also helps you allows fast search and insertion and delete on sorted information as well. And you can even implement it using arrays or priority queues as well. You also can use it for databases and other sort of things. Thank you so much for listening, and I hope you have a great day.